And by this, we will be transferring to the second speaker of the first session, who is Jan Jančar, a PhD candidate here in Brno at Masaryk University, under the supervision of Vašek Matyáš, also present upstairs and also catchable during the breaks if you're interested. Jano is a supported PhD by Red Hat and does research into cryptography, security, and all sorts of other things he will be talking about. So, ladies and gentlemen, Jan Jančar.
All right, let's see if this works. So, I should do this. You should say something, okay. And then, oh, Jesus. There we go. All right. Okay, so thank you, Martin, for the introduction. As he said, my name is Jan, but I want to first mention that this is joint work with all of these great people. Some of them were supposed to be here, but they aren't. But as Martin mentioned, Vašek is here. So I'll be talking about analyzing the security certifications landscape and trying to answer this big old question that whether certifications actually help security. And it doesn't matter if you don't know security certifications at this point. I will get into them very well. So, but I want to start with the story. So back in 2019, we discovered this group of vulnerabilities. We were doing research into testing elliptic curve cryptography. And my microphone stopped working there for a bit. I hope everything. Now it, yeah, okay. And we had this tool called EC Tester, which was testing these implementations, and we discovered this timing sidechain of vulnerability in some elliptic curve digital signature algorithm, in 5 open source cryptographic libraries, and in 1 smart card. So it was the Athena ID Protect smart card. It was both common criteria and FIPS certified. Now, as this was sort of a big deal, we wanted to do responsible disclosure. So we did responsible disclosure for the libraries, and that was pretty easy. We analyzed the sources. These are open source, right? And after a few emails back and forth, we could get the developers to fix these issues. However, for the smart card, we had no source available, and we can't debug, right? So it's a smart card. It's closed source, and also another issue is that Athena no longer exists. It was sold to NXP, so as a company we really didn't have anyone to contact. We could contact NXP, and we did that, so that was the step. However, what about end users, right? So we want to also notify end users. We want to make them aware of this vulnerability. So who are they? How do we know who are the end users of this? Well, NXP said that they notified affected customers, but I sort of think that it will have a hard time knowing what all the possible end users are and all the customers, and they won't be able to notify all of them. And we also want to sort of get to know where this vulnerability comes from, right? We want to know what actually is the issue, what's the underlying cause, and whether other implementations share it. So in the smart card space, there is often this sharing of components. So you have a smart card that's sort of comprised of, there is some chip. On that chip there is some cryptographic library or firmware. On that there is some operating system, and on top of that you have some applet. So there could be other smart cards that are using the same sort of vulnerable component. And NXP pointed us to the underlying Atmel crypto library, but then sort of provided no details, right? Because of course they wouldn't tell us more. Because we didn't sign any NDAs or something like that. So let's look to security certifications for some more info, and you will see why this makes sense in a bit. So security certifications are trying to answer the question of how to have confidence in security without implicitly sort of trusting vendors or vendors' claims. So like, yes, this is definitely a secure product, just trust it will be fine. And so globally, the common criteria standard, also for payment cards, is the EMVCO standard. In the US, this is FIPS 140, and you basically need to be certified via these schemes if you want to sell to government or even to some sort of private entities. And how certification roughly goes for the common criteria is that it's a certification that the product adheres to some security target. So security target is a document that the vendor sort of creates or gets created for them, which has some security claims, right? It has some claims of how the product has some security functions and assurances. The vendor then sort of comes this document and with conduct to the certification body and with these materials, which an independent lab then evaluates, right? So the lab evaluates the vendor's claims of security, and if all goes well, in the end, the certification body issues the certificate, issues a certification report of how the certification went, and also the certificates are released along with most of these documents, while some documents remain private. And what was also interesting is that these certificates are intentionally recognized, so you can have certification in the Netherlands, for example, while it will be recognized over the EU or worldwide. Now, what also is sort of used sometimes is that the security target can point to a protection profile instead, and a protection profile is really sort of a security target for a product class. So it's a solution to the problem so that not every firewall vendor needs to specify their own security target for what a firewall should do and how a firewall should be secure. There is just one firewall protection profile. The vendors can sort of adhere to that. Now, I'll give an example of how certification-related documents look. So on the left, you see a page from the certification report. On the right, you see a page from a security target. And these are two documents from the certificate of the Athena ID Protect smart card that I mentioned at the start, right? So this vulnerable smart card where we found a sort of big cryptographic issue. And these already contain quite a lot of interesting. So on the left, you see that so-called certificate ID, which is a unique identifier of that particular certificate. And then you see lots of interesting data about what is actually certified, right? So it's a smart card, it's a Java card, there is this applet on it with some version, and there is the chip identifier, again with a version, and also this toolbox version, which is some sort of cryptographic library. And if you go to the security target, you get even more details, like concrete versions or which allow you to identify the product. And what's really interesting for us is that you get references to other certificates. So here you see the reference to a certificate of some particular chip. And the most important is you see a reference certificate for a cryptographic library. And if you look there, I will just read it for you. It's the Atmel toolbox of a particular version. Right? So this is how we were actually able to find the vulnerable certificate, the vulnerable component out of this whole system, which likely introduced the vulnerability. So based on all of these documents, we can try to build a graph, right? So back to the vulnerability case, we have the vulnerability. It affects this smart card, which is certified, which uses this toolbox, which likely contains the vulnerability. And then we can where is this toolbox used elsewhere, and it's used in these 7 other certificates, which are also sort of smart card certificates. And then the vulnerability can likely be present in some of those certificates, certified products as well. Of course, these products might not use the actual functionality that's vulnerable, or they might have some sort of other mitigation or so on, but there's a likelihood that the vulnerability is somewhere in there. And we found some other very interesting piece of information through these certificates. This note at the bottom is from a security target of the Atmel toolbox, which basically says that, it said something somewhere before, that there are 2 sets of functions for elliptic curve cryptography. One is called fast, and the other is called secure, which you might sort of notice where I'm going with this. And there's this node that says the fast functions do not offer any sort of like side channel or attack protection and must not be used for secure data. Currently, this toolbox had some functions for cryptography which were not secure. And it likely happened that the Athena developers used these fast functions instead of the secure ones just because they were faster, and that's how the vulnerability got introduced. If you go to the FIPS case, we see again, Athena is also FIPS certified, so we can find the certificate. We see that it uses this ECDSA algorithm module 214, and again, this is used in 3 other certificates, which use the affected functionality are also likely vulnerable. Now, we did all of this manually, right? So back in the day, there was roughly 5,000 CC certificates, roughly 4,000 FIPS certificates. But doing this manually has lots of issues. So there is no common format to really reports or the security target. certification bodies have their own report formats, and the security targets are made by vendors. They also have their own formats. So really, it's just a bunch of documents. There's no search. You just get like 20,000 PDFs. There are typos. There are PDFs that are not PDFs. There are documents. An extension changed. There are errors in the data. So Common Criteria has this listing of certified products that you can download. It's a CSV file, but it's not a valid CSV file. It's messed up. There are issues there. There are duplicates. There are, again, typos and so on. And these documents are just scans, right? So you just have like a 70 page of pictures that you need to do OCR on if you like want to search on them or so. So doing this manually, you can go crazy. And I mean, I looked like this when I was doing this for the Minerva vulnerability case. So what can we do to sort of clean up this mess or see some insight into all of these 20,000 documents without going crazy? Well, we can try to automate some stuff, right? So this is our tool. It's called SecSearch. You can see it on secsearch.org. Later after the talk, I suggest you all go and check it out. Hope the web works. And it's a tool for processing and analyzing these security certificates. And this is its sort of main line. So these first 3 stages are kind of boring. We just download the certificates from the, let's say, Common Criteria portal, and then we do some sort of PDF to text conversion with optional OCR if we sort of detect, okay, this is likely a scan document or our output of the text conversion is messed up, because PDF is a terrible standard. It's really we are having so much issues in just like going from PDF to text and getting reasonable text out of it and getting the insights that we want, is that I never want to work with PDFs ever again. But let's get to this more interesting stage, which we call feature extraction, but really it's just a bunch of regular expressions. So we can extract all of these interesting insights from the certificates, such as the security assurance components, or functional requirements, the security levels, or references to other certificates, for example, because we have the IDs, or things like cryptographic algorithms that are there. However, there's this main limitation that we have context, right? Since this is just regular expressions, if we match, like for some cryptographic algorithm inside a security target certificate, what does that actually mean, right? Does it mean that this certified product uses that cryptographic algorithm? Or does it mean that the certified product does not use this algorithm, or it must not use this algorithm? Or does it mean that it's implemented there, or it's implemented elsewhere, or it's like called, or it's deprecated? You know, there's a lot of this context or relationship that we do not really get. We hope that by future work, by trying some natural language processing, we can sort of try to get there. Although it is likely a hard problem, because for example, these algorithms and so on, they might just be listed in a table, and then the table has some header like few pages off, and the header says algorithms used, and there's really, like, even as a human, you have a hard time to understand like what's actually meant there and where this is. Now the next step in the pipeline is the mapping of vulnerabilities. We call it unsupervised learning, but again, it's not that hard, and it's quite simple in the end. So the question there is, which certified products are affected by a given vulnerability? So the hope is to automate this process, which we did manually, where we went from, okay, we have a vulnerability in this product, this Minerva vulnerability in this Athena smart card, and how do we get to the certificate and the other affected certificates? And our solution, which is sort of a simple one, is to CVEs to certificates via their CPEs from NVD. So I've just said a bunch of acronyms, but don't worry, I will explain them. So common CVEs stands for Common Vulnerabilities and Exposures. It's basically a huge database of vulnerabilities along with some description, severity, and so on. And NVD is a NIST vulnerability database where they basically take these CVEs and enrich them with some more of their data. And one important part of their data that they enrich is that they add CPE. So a CPE is a common platform enumeration. It's basically a text string that looks like this, that just describes what the affected or the vulnerable product is, right? So in this case, the vulnerable product is some sort of Infineon-made RSA library with this version. So good, kind of understandable. Now, we can map this to the certificate name. So this is an example of a really long certificate name. It's a common criteria certificate. And so we can go, okay, vendor, it's there, fine, we move on. RSA, that's also library, fine, well, we have libraries, but if we stem all these words, we can get library out of that, so the match will be good. And we also can match the version. So this is a very sort of simple, well, rule-based plus similarity-based algorithm that allows us to map vulnerabilities to certified products and to certificates. Now we evaluated this. We got like we got vulnerabilities to 600 out of the 5,000 or so CC certificates, but a lot of these certificates have tons of vulnerabilities. So these are often like operating system certificates, which over the years they just accrue a lot of vulnerabilities. We also manually evaluated the precision of this. So we basically looked at a random sample of these matches where our system said that this certificate is affected by a given vulnerability, and then went, will a human say that this is the case? So we evaluated this based on PE and got a precision of 89%. This obviously has some limitations, right? We are only matching the CPE to the name of the certificate, so we are lots of data, both in the vulnerability case, right? So from the CV, there's the description, there's lots of context there, and in the certificate, we have lots of data and security target that we are also not using. And also, this is just a hard problem in general, right? Like saying whether a given vulnerability or like CVE affects some version of some product in some configuration. Even a human might have a hard time evaluating that, so doing this in an automated way is really pretty hard. We also do not evaluate in sort of configuration detail. So if the CV says that, yeah, you need to enable this option or that option to be vulnerable, well, we cannot really do anything about that or get this information from the certificate. And also, this data is noisy. So what NIST provides, in the end, there's some human there that creates these CPEs, and also for the certificates, there's a human in line that creates this data that we use. Now, we can try to use this to answer the main question I posed at the start, is whether certifications help security. But again, that's a sort of hard question, or maybe more of a philosophical one. We can try an easier one, whether high assurance levels, which is a thing in common criteria, right? You can have a product certified to different assurance levels, but the higher assurance levels lead to less severe vulnerabilities or lead to fewer vulnerabilities. But it is also a hard question because of the words lead to, right? So the causality, we will have a hard time doing that with our data. But even an easier one is whether high assurance levels correlate with less severe vulnerabilities or with fewer vulnerabilities. And luckily, we can try to answer this. And luckily, they do, but just slightly. So there is both a slight negative correlation with both the number of vulnerabilities of a given certificate and with the severity of vulnerabilities of a given certificate with respect to the assurance level of that certificate. Now, moving on to the next part of the pipeline, these are certificate references. So here we want to understand what certificates refer to other certificates and why they do that. And our solution, which is, again, partial at the moment, is to extract certificate IDs via a regular expression, then sort of canonicalize them and match them to other certificates, right? So if we see that security target contains a certificate ID of a different certificate, well, we add it to a graph, and then we can analyze this graph. Why I say this solution is partial, it's because of the part, right? The reasons, again, are a hard problem. There can be many reasons certificate would reference another certificate. It can be a component that's used. It can be a recertification. It can be sort of simultaneous certification. It can be, whatever other thing that the authors of the certification report sort of wanted to. And even as a human, you sometimes have a hard time figuring out, okay, why is this reference? Is it really used? What parts of it are used? And how is it configured? And so on. So that's quite a hard problem. But we plan to try, again, natural processing to at least solve the easy cases, right? The easy cases where somewhere in the document we have a sentence, okay, this certificate uses this other certificate as a component, right? That we could do. That will solve quite a lot of our problems. Now, we all are kind of doing this in the hope that it will be used by the community, used by people. So for that, we built this web front end, which I'll talk about for a bit. And with this web front end, which you can check out, or you can scan these QR codes for 2 demos, yeah, they're big enough, is that you can use this web front end to both browse all of these certificates and all of our extracted data from them. You can do search and filtering, so there's like both full text search of all of these documents and like proper filtering. This data is updated daily, so we run like nightly updates, and there's an export of this data available. So if you want to use our tool to do some analysis, open a Jupyter notebook and plot some graphs of how the certificate landscape is evolving, you can do so without running this analysis, without downloading 20,000 PDFs and taking hours. You can do that because we have the data and it's updated daily. But what's really, really important, or I think a really nice feature, is that you can get notifications. So if you subscribe via email, you can get notified on changes of the associated data to a particular certificate. This is nice if something changes in the description of the certificate, or if we add some new heuristics, some new data extraction, you will see that we extracted this from the certificate. Or you can get notified of new vulnerabilities. So again, we do the updates from the CV database daily, and we map it to the certificate. And if you subscribe to receive these updates, you can receive them. And we can even use this graph of references that I mentioned to notify you of not only vulnerabilities in that particular certificate you subscribe to, but also in other certificates that your certificate is referencing, right? So if you assume reference means that it's used as a component, we can sort of notify you of vulnerabilities potentially affecting your certificate because they are somewhere in a component that your certificate uses. And now with this, we hope that vulnerability researchers can use this to gain information on certified products. So the thing that we did with the Minerva case, we already saw some other teams do the work, do it manually. It takes a lot of work, and now we have this automation. We hope that evaluation labs can use it to know where the space is moving, what other labs are doing, what things are getting certified, and what the space is really doing. And we hope that vendors can use it to know what their competitors are doing, do this analysis of similar to the labs of what is getting certified and how that's going. And finally, the end users can get these notifications for vulnerabilities so that so that they know if a vulnerability affects their product that they are using. So with that, we built this open source tool for now the security certificates in the landscape. Web front end that I hope you can all check out. And thanks for that, and I hope you have some questions.
Indeed, as you hoped, there are some questions ready for you. And the first one is from Ivan Nechas asking whether there's some push for standardizing a format for certificates instead of having the almighty PDFs everywhere.
It will be great, but I think there's actually a push against that. So I don't know, like some information from another person that says like there was some idea of doing that, but then it was pushed back for some reason. I don't know. It would be great if this was all in machine readable format with proper descriptions of what actually the certified thing is that you could match, and you would have the versions and the components and the packages and so on. It would be so great, but yeah, we just have PDFs.
I'm not sure we will have that world anytime soon, but
yeah,
we'll
within
see.
my lifetime, maybe.
Second question. You mentioned you have processed 20,000 certificates, and the question says that it sounds like a rather low number compared to the amount of products out there on the market. And it asks whether there are other certifications that can be included to cover more products.
Yeah. Okay, so common criteria is, like a large part of common criteria is just smart cards. That's like the most dominating category. So these get certified because you need that, for example, for like electronic IDs in Europe. If you want, you need to have a certified device. And FIPS is needed for governmental use in the US. But yeah, there's also EMVCo, but that's most often, again, that's payment cards, and that's also often bundled with common criteria. So they're really like, we could add EMVCo, but there really aren't any more certifications that we are sort of interested in that would add many products. It's just that, yeah, these are the certified products, and other stuff doesn't get certified that much.
Okay. How much changes can be made to code or hardware without having to recertify again? More of an implementation / applied question from the developer standpoint than the analysis standpoint.
Thank you. That I do not know, or cannot really properly answer. I'm not an insider to this space, right? I'm not an employee or a vendor that gets certified. But I know that this is one of the main issues of this whole certification process, that if you want to make change, like products evolve rapidly, and the certifications freeze them at some point in time, and then even if they have issues, you have a hard time of fixing the issues. So maybe one answer I could give is that I know some random smart card certificate that started the certification process 3 years before the certificate was issued. And so it was frozen in time for 3 years or something, or minor updates along the way, and then it got a certificate, and then it's again frozen in time, but it's already outdated by that point, right? So yeah, that's one of the issues.
The next one is more of a compliment from Tommy Unger, that you did a lot of data labeling on the data, and he just says bravo for all the work that was done in there. And then a question from someone asking whether there are legal requirements for devices to be certified, or whether many of the devices out there are uncertified, or whether you can comment on this in some way.
Yes, there's definitely legal requirements. As I said, in the EU, if you want a government-issued electronic ID, right, that has to be a certified thing. Indeed, I mean that's an issue in Slovakia, where their certificate expired and now they have to reissue some of the IDs and so on. So yes, there are definitely governmental requirements for mandating certifications.
Do you have any plans to include EU-based certifications in the analysis in the future?
Sure. Yeah. I mean, yeah, we try to include what we can do. I mean, we have some ongoing work on including more information from the pages of the certificate schemes themselves, from country pages, not just from the centralized database. They have more information at some point, and yeah, we try to include everything from security certifications.
Yeah. Let's thank the speaker again. Thank you for the great talk. One more comment, actually also written in Slido, is that Jaroslav Reznik from Red Hat, that's cooperating with Jano on the research, it's also present in the room. And if you're interested, asking about the common criteria of FIPS certifications or the processes from the engineering point of view, feel free to approach Jarda in the audience and ask during the breaks or the networking. That concludes the first two talks of the event, with a couple of housekeeping announcements at the moment. First, definitely do approach the speakers during the break. They will be available for questions. They will try to be somewhere near here below the stage. Then the event is not only about the speakers. Definitely do think of the other attendees as well, because it was invite only, and there are great attendees here. Check the attendee list if you haven't already. Check the nameplate on the tables to find out who is here, what they are interested in, and do talk among yourselves apart from also talking to the speaker. Last housekeeping bit, many of you may not have noticed there are extension cords below all the tables here downstairs, though sometimes they are conveniently hidden in the middle just next to the floor, so some people may not have noticed. Unfortunately, there are none on the gallery. That concludes the first session. Thank you all for paying attention, and see you in half an hour for the other session.